Today we're going to use what you've learned about finding trig ratios to real life. Here you can see a picture of a canyon, and what we can actually use the trig ratios for is if you're standing at one point, A, and then you could walk to another point, B, and you can measure the angle across the canyons. And here you can form a triangle, a little bit off on this picture, and you can tell the distance between the two canyons by using trig ratios. So let's look at our example 5 in our notes. So if we're hiking on a canyon, we can start at point A, and then we have point B that we could walk to. And across the canyon, you have point C. Now, the distance between B and C measures an angle of 90 degrees. Okay, so you can look straight across to C. Now, the angle at B between A and C is this 76 degrees. Okay. So when you walk from point A to point B, that distance is 2 miles. And then we want to use our trig ratios to calculate how wide the canyon is from point A to point C. So let's see what's given. If the angle here at B is 76 degrees, the 2 miles would measure the adjacent side of our right triangle. And we're looking from the distance from point A to point C, which is actually opposite the 76 degree angle. So I'm going to use a trig function with opposite and adjacent, which means we can either use tangent because it's opposite over adjacent, or we could use cotangent, which is adjacent over opposite. It's actually easier if the variable is in the numerator, and since we're looking for the opposite, or we can call that x, let's go with using tangent. So let's write down the trig function we're going to use. Let's plug in what we know. We know the angle is 76 degrees. The opposite side is x and the adjacent side is 2. Solve for x by multiplying both sides by 2. So the distance x is the same as 2 times tangent of 76 degrees. Then you just need to calculate this in your calculator. 2 times tangent 76 degrees. Your answer should be approximately 8 miles. So that's how wide the canyons are. Next, try and find the distance between B and C. We can go through finding the distance between B and C tomorrow. Next, let's look at something new here, angle of depression and angle of elevation. So if you are standing on the ground and you have a building, if you're standing on the ground and you're looking up to the top of the building, so when it's horizontal and then you look up, we will call that an angle of elevation. But if you were standing at the top of the building and then you're looking down, okay, so it's horizontal and then look down, that would be called an angle of depression. So elevation when it's horizontal and up, depression horizontal looking down. Let's read example 6. In example 6, we have a little parasailer attached to a boat and it's flying in the air. Now the rope attaching it is 72 feet long. And the angle of elevation from the boat, so it's horizontal, elevation horizontal to up would be 28 degrees. So you can see here we can form a right triangle. We want to estimate how high the parasailer is from the boat. So there would be my variable x. So again, now that we've drawn our triangle, let's label what we know. If the angle is 28 degrees, notice the x is opposite the angle. The 72 would represent a hypotenuse. Now we know nothing about the adjacent side, nor do we care about it. I'm not going to label it at all. So I can see that I have opposite and hypotenuse labeled, which means I'm either going to use sine or cosecant. Let's try writing our sine function. Sine is opposite over hypotenuse. Let's plug in what we know. We know the angle is 28 degrees. The opposite is x, and the hypotenuse is 72. When x is in the top, it's very easy to solve. Just multiply both sides by 72. Notice I keep putting the 72 in front of the trig function, and that is a good idea to make sure you type it in the calculator right. So type 72 times sine 28, Make sure your calculator is in degree mode, otherwise you're going to get the wrong answer. And the approximate distance will be 33.8 feet above the boat's water.